Do you think space is silent? Well, it's not. In this video, I'll take you on a journey through the scariest sounds that shocked everyone in the space community. They are real sounds captured by NASA, and trust me, they only get more terrifying as we go on. So keep watching until the end. Let's start with a special one. The next sound we'll explore comes from an incredible sight in deep space. Two galaxies locked in a cosmic collision. They're known as the Mice Galaxies, or NGC 4676A and NGC 4676B, and they're located about 300 million light-years away in the constellation Coma Berenices. These galaxies are in the middle of crashing into each other. Gravity is pulling stars, dust, and gas from both galaxies, creating long tails that stretch into space, which is how they got their nickname, the Mice. Even though it looks chaotic, this kind of interaction is actually common in the universe. Eventually, these two galaxies will merge into a single, larger one. NASA used Hubble's image of the Mice Galaxies to create a sonification that lets us hear the intensity of this event. The sound starts from the top of the image and moves downward, matching the way our eyes would scan the picture. Brighter stars in denser areas create higher-pitched, sharper sounds, while the darker regions stay quiet or low. As the sound plays, you'll notice sudden spikes and swirling tones. This reflects the motion and tension between the two galaxies as they pass through each other. It's a dramatic and eerie reminder of how active and violent the universe can be, even if we usually think of space as calm and still. So when you hear this, try to imagine entire galaxies, each with billions of stars, colliding over millions of years. And now, for the first time, we get to hear a small piece of what that might be like. If you thought this was amazing, wait until you hear the next one. Now we come to something truly strange and beautiful. Hoag's object. At first glance, it doesn't even look real. This galaxy is shaped like a perfect ring, with bright blue stars forming a circle around a golden core. Unlike most galaxies, which are spiral or elliptical, Hoag's object is a ring galaxy, and it's incredibly rare. Located about 600 million light-years away in the constellation Serpens, this object has puzzled astronomers since it was first discovered in 1950. The outer ring contains hot, young stars, while the center is made of older stars. What's missing is any connection between them. No spiral arms, no bridges of matter, just a clean, empty gap. How this galaxy formed is still a mystery. NASA's sonification of Hoag's object captures its symmetry and stillness. The sound travels from left to right across the image. As it reaches the bright ring of stars, the tones become higher and clearer. Then, as it passes the empty space between the ring and the core, the sound dips, almost like a sudden pause. Finally, it rises again when reaching the golden center. Listening to this sonification feels like hearing something alien. Organized, calm, but a little unsettling. The perfect shape combined with the strange, echo-like tones makes this one of the most haunting sounds in NASA's collection. It reminds us that even in the vast randomness of the universe, nature can create structures that are almost too perfect to believe. And when you hear this ring, think about what it means. Stars orbiting quietly in a near-flawless circle, far beyond anything we can reach. If you thought this one was easy on the ears, next up is something far more intense. I am talking about the bullet cluster. This is one of the most famous and powerful collisions ever observed between two galaxy clusters. It's located about 3.8 billion light-years away, and what makes it truly special is how it provides direct evidence of dark matter. The bullet cluster is actually made of two separate clusters of galaxies that have crashed through each other. The bright pink areas you see in the Hubble image show the hot gas detected by X-rays, which contains most of the visible matter. But the dark matter, which doesn't emit or absorb light, passed through the collision almost untouched. Scientists note this because they mapped it using gravitational lensing, the way the cluster bends light from galaxies behind it. The sonification of the bullet cluster reflects this hidden chaos. The sound moves from the bottom to the top of the image. The gas shows up in sharp, high tones, while the locations of dark matter appear as deep, rumbling pulses. These lower tones represent the invisible mass that we know is there but can't actually see. Listening to the sonification is like hearing two waves crash into each other. There are layers of sound, some fast and light, others slow and heavy. It gives the sense of enormous energy being released as two massive objects collide at high speed. What's striking is how the sonification helps us feel the difference between what's visible and what's hidden. The bright gas makes one kind of noise, but the true weight of the bullet cluster is in the parts we can't see. And those parts rumble quietly in the background. This is space at its most powerful and most mysterious. Next, we travel to a galaxy cluster known as Abell 370, located around 4 billion light-years away in the constellation Cetus. At first glance, the Hubble image of Abell 370 looks like a beautiful collection of distant galaxies. But look closer and you'll see something strange. Long, stretched arcs of light. These aren't errors or distortions. They're real, and they're caused by something called gravitational lensing. Gravitational lensing happens when a massive object, like a galaxy cluster, bends the light of galaxies behind it. The intense gravity of the cluster warps space itself, almost like a magnifying glass. This bends and stretches the light, giving us a distorted but incredibly valuable view of galaxies that are even farther away. In NASA's sonification of Abell 370, the sound moves from left to right across the image. Every time the scan passes over a galaxy, you'll hear a note. Brighter galaxies produce louder tones, while fainter ones are softer. But what makes this sound truly unique is how the arcs, those stretched galaxies, create long, drawn-out audio effects that stand out from the rest. The result is a smooth but slightly warped piece of sound, almost like listening to an instrument being bent or twisted as it plays. There's a surreal quality to it. Fitting, since what you're hearing is literally the distortion of space caused by gravity. Abell 370 isn't just visually fascinating. It's also one of the best examples of how space can act like a lens, showing us things we could never see otherwise. And thanks to sonification, we don't just see the lensing, we hear it. Now let's explore another example of gravitational lensing, this time from a different lensing galaxy cluster captured by Hubble. Just like Abell 370, this cluster bends and distorts the light from galaxies far behind it. But this one stands out for the dramatic curves and arcs scattered across the image, a clear sign of space being warped by massive amounts of gravity. These arcs aren't the galaxies themselves, but stretched versions of them, the light paths bent on their way to Earth. It's a reminder of just how powerful gravity is. It doesn't just hold things together, it actually changes the shape of space itself. In the sonification, NASA converts this warped view into sound that moves from top to bottom. As the scan passes over bright galaxies, stars, and stretched arcs, you'll hear a combination of tones and sliding effects. The more the light is bent, the more distorted the sound becomes. The arcs create eerie, bending noises, almost like a musical note being stretched or bent out of tune. It's subtle at first, but then you notice the way the sounds twist and drift, just like the light in the image. There's something slightly disorienting about it, and that's the point. You're not just hearing galaxies, you're hearing how the fabric of space is being pulled and shaped by gravity. These sounds help us imagine the forces at play in galaxy clusters, the sheer weight of dark matter and regular matter bending space in ways we can't see with the naked eye. But with sonification, we can finally sense it in a new way. Finally, we turn our attention home, to the center of our own galaxy, the Milky Way. You might think our galactic core would be calm and steady, but it's actually one of the most dynamic and chaotic places in the entire galaxy. At the heart of the Milky Way lies a supermassive black hole called Sagittarius, a star. Surrounding it are dense clouds of gas, dust, and tightly packed stars, all swirling around in extreme gravitational forces. It's a place of constant motion and energy, far beyond what we experience here on Earth. NASA's sonification of this region is based on data from both the Hubble Space Telescope and the Chandra X-ray Observatory. The image combines visible light, infrared, and X-rays to give us a detailed view of what's happening in the center. Then, using sonification, scientists converted these layers into sound. The scan moves from left to right. As it passes through bright stars and gas clouds, you'll hear high-pitched twinkles and rising tones. But the most intense sounds come from the central area, near Sagittarius A star. There, the audio swells with deep rumbles, quick pulses, and sharp notes, reflecting the high-energy activity going on around the black hole. It sounds busy, almost overwhelming. Yeah, and that's accurate. The center of our galaxy is a place of turbulence, where stars are born, pulled apart, and spun around at high speeds. This sonification gives us a new way to feel just how alive and unpredictable it really is. Hearing it makes the Milky Way seem less like a quiet background and more like a complex system, full of motion, pressure, and energy, with a black hole at the wheel. What did you think of these sounds from space? Let this community know in the comments below.